which is measures of variability. So where measures of center are like one number to represent the whole pile of data. Measures of variability give you a measurement of how much the spread is of the data, like how far apart the numbers are, or what the distribution looks like. Okay, are there lots of numbers all packed in one spot, or is it just they go from very low to very high, and there's lots of numbers spread all over the place. Okay, so there's different measures of variability to represent those kinds of values in a data set. The first one, like we just talked about, is range. Range you have done before. Range in statistics is the difference between the smallest value and the largest value. So you find the largest and smallest values of your data and you subtract them. Okay, so on this line plot or dot plot, the biggest one is 38, the smallest is 10. So the range of this is 28 minutes, 38 minus 10. Here's a bunch of ages of children. They range from 27 down to 4, right? So the range of ages is 27 minus 4, or 23 years. All right, range, pretty simple. The next one, and I don't know that you've had this before. So the next measure of how spread out the data are what are called quartiles. Quartiles start with the median, okay? Quartiles basically split all of your data into 4 equal sections. Okay, so the median, which we've already learned about, splits the data in half. That is the middle value of your data points. Well, if you take the lower half of your data, okay, and then you split that in half, that splits your data into the first quartile and the second quartile. Okay, so you're basically splitting all your data points into 4 equal numbers of data points. But you use the median rules for each one. So when you calculate the median, if there's 2 numbers in the middle of your data, then you find the average of those 2 numbers, add them together, divide by 2. When you take once you take that median number out, then you look at all the lower half numbers and you find the median of those numbers, right? You find the middle of those numbers using the same rules. That's what you call quartile 1 or Q1. And then you do the same thing with the upper half of your data, split them in half, and that line where they split in half, that number where they split in half, is Q3. All right, so, and then what you do is your measurement of variability is you take the difference between your Q1 value and your Q3 value, okay, which is called the interquartile range, sometimes abbreviated IQR. So the interquartile range is the difference between your Q3 value and your Q1 value. You subtract them, okay? And it basically tells you how spread out your data points are. Okay, so here is an example. What are the measures of variability for the data in this table? It's the number of Olympic silver medals won between 1976 and 2008. Unfortunately, our books are pretty old, so this is the statistics we get in there. Okay, so you got to look through this table and identify the highest and lowest numbers. And actually, what you have to do is put them in order from least to greatest. You're going to have to do that anyway to do the interquartile ranges and find the Q1 and Q3 numbers. So you might as well start by putting them all in order from lowest to highest. And then you can see what the biggest and smallest numbers are and get the range. So the range of silver medal wins is from 0 to 61. 61 minus 0 is 61 medals. So that's your range. That's your first measure of variability. 61 medals is the range. Okay, then you have to find your median, which is a middle measurement, but you need that to then calculate the first and third quartiles. So the median, the middle number here, because there's an odd number of data points, the middle number is 34. That's the median. Okay, so there are 4 numbers in the lower half. We split them in half. Okay, find the median of these 4 numbers, which means I need the average between 24 and 31, which is 27.5. That's my Q1 number. And then the same thing for the upper 4 numbers. That's the split between 38 and 39. So you should be able to do that one in your head. 38.5 is your Q3 number. So that's your first quartile and third quartile numbers, 27.5 and 38.5. The interquartile range then is subtracting those two numbers, and that answer is 11. So the interquartile range for this set is 11, which is pretty good size, right? For the pretty good spread for the numbers of metals. Okay, small interquartile range means that the data is packed in most of them are close to that median value or closer to that. And a larger interquartile range means that the data are spread out. There's more variance in the data. All right, now another point of variability in your data is sometimes there are numbers that are way bigger or way smaller than the majority of the numbers, okay? And those are called outliers. Now, typically, you can look at the data and kind of identify an outlier, right? You'll say, oh, that one's way off. It's way higher or way lower than most of the numbers in the data set, okay? But there's actually an official definition of an outlier that is based on the interquartile range and the Q1 and Q3 values of your data. So officially, an outlier is any data point that is more than 1.5 times the interquartile range beyond the Q3 or Q1 values, okay? So in order to identify outliers officially, you have to find the interquartile range, which means you have to find the median, put all the numbers in order, which these are already in order for you, and that's why they show you that the median is this middle number, the cat, right? Your first quartile, then there's 3 numbers in the first half, so your first quartile is 15. Your second or your third quartile is the middle of the upper 3 numbers, so that's 35. So 35 and 15 are your third and first quartiles, means the interquartile range is 20, 30 minus 15. And so to check for outliers, it's 1.5 times the interquartile range. 1.5 times 20 is 30. And you subtract 30 from your first quartile number. 15 minus 30 is negative 15. So you don't have any outliers on the low side because it would be a negative number. And on the high side, 35, you add 30 to the third quartile number. Okay, so you add your interquartile range to the third quarter value, the third quartile value, which is 35. So 35 plus 30 is 65. So then you look, well, do I have any values above 65? And I do. This one, the cheetah is an outlier. Okay, it is too far outside of the majority of the data points. Okay, what do you do with outliers? Well, sometimes you throw them out. Okay, you kind of disregard them when you are doing other analysis of your data. All right, now here's one for you to do. Find any outliers in the data set. Find the outliers in the data set. So first, since you need to find what the interquartile range is, you need to put the numbers in order so you can find the median and the Q1 and Q3 values. So we'll put them in order. And when you look at that, it looks, without any calculation here, it looks like 155 is kind of off from the other numbers. It looks like that's an outlier, but let's figure that out officially. So officially, to find out if it's an outlier, we're going to need to find the interquartile range, 1.5 times the interquartile range, and see if it's that far beyond the third or first quartile values. So we start with all the numbers in order again, and we find the median. So there are 8 values here. The median then is 112.5, halfway in between 110 and 115. Your Q1 value is, there's 4 numbers in the lower half here, and halfway in between the middle 2 numbers is 102.5. And your Q3 value, there are 4 numbers in the upper half, and the 2 middle ones are 120. So Q3 is 120. Your interquartile range then is 120 minus 102.5, or 17.5. So this is your interquartile range. To determine outliers, we look at 1.5 times the interquartile range. That's 26.25, 1.5 times 17.5. So our outliers are either 26.25 below Q1, 102 minus 102.5, 26.25 is 76.25. You do not have any values lower than 76.25, so no low outliers. Or on the high end, you add this value to your Q3 number, 146.25. And sure enough, 155 is greater than 146.25, meaning that 155 is officially an outlier. All right, so what do we use measures of variability for? Well, you use it to compare data because it is helpful to look at whether things are varying more in different sets of data. So this is a comparison here of how many counties there are in different states in the West and in the Northeast. Okay, so first, so compare the ranges of these two things. So the range for the Northeast is 56. I'm sorry, for the West, it's 56 minus 15. These are already in order, which is nice. 56 minus 15, or 41. Okay, and in the Northeast, it's 3 counties, which is probably Rhode Island, and 62 counties, which is probably New York. So there is quite the range there. The range is 59 for the Northeastern states. A lot more variability in the Northeastern states than in the West. Okay, but is there an outlier? Well, again, you look at the numbers and you're like, well, this 62 looks like an outlier. I mean, there's some numbers that are low here, so there's more than one. And the Western states, there's a big range there, but they kind of are clumped together. So, but this 62 is definitely out of control. You really don't need to do the calculation to say this is an outlier. It is very obvious, twice as big as the next highest number. But we'll do the official calculation here. Is it 1.5 times the interquartile range bigger than Q3? Okay, well, you got to find your quartiles then for each data set. So there's 10 values in each one. You don't really need the median numbers here. I put them in there, but you don't really need those numbers. But you do need the middle number of the lower half, which is 23 for the West and 8 for the Northeast. That's your Q1 values. The middle value for the upper half of data for each one, 44 for the West, 21 for the Northeast. Those are your Q3 values. Your interquartile values, then you subtract them. 44 minus 23 is 21. 21 minus 8 is 13. So 21 and 13 are your interquartile ranges. Multiply them by 1.5 to get 31.5 and 19.5. And then you add or subtract those values from your Q1 and your Q3. So subtracting from Q1 gives you a negative number, so there aren't any of those. And on the Western side, adding would be a Western state would have to have more than 75.5 counties to be an outlier, so there aren't any. On the Northeast side, the low end is negative again, but the high end, 21, your Q3 number, plus the 1.5 times the interquartile range, which is 19.5, is 40.5, and the 62 is way above the 40.5, which is why it's very obvious that this number is an outlier. Okay, so your observation would be, oh, there's one outlier. Otherwise, the Northeastern states have way less counties as far as the center is concerned, but they also have less variation because there's not as much change there. The Northeastern states' interquartile range is only 13 compared to 21 for the Western states. Okay, now how does the outlier affect that measure of center? If you threw it out, okay, and you did the mean, you can see that with the outlier, it makes the average, the mean, 17.7. And if you left it out and just used the other 9, it comes out to 12.78, which is a lot more representative of the center of all of these numbers. Okay, so if the outlier is not included, the mean goes down by about 5. the median and the mode are not affected by this because of these two numbers that are the same here. And the mode is also still the same. Okay, but it definitely affects the average. And that's what outliers do, which is why if you have outliers, you use median instead of average, instead of mean, to represent the group. All right, one for you. Here's calories from fruits and vegetables, a problem from page 444. So compare the ranges of the fruits and vegetable calories and see if there are any outliers. The range for fruits and vegetables. So the range for fruit is 30, 80 minus 50. And the range for vegetables is 20, 50 minus 30. These are nice, easy numbers you can do in your head. Same thing with finding your quartiles, right? So the medians are right here in the middle. So that means that your quartiles are here and here. And these numbers are pretty easy to get. 50 and 35 for your Q1 values, right? Because they're the same numbers. Okay, so 50 and 35. Your Q3 values are 60 for fruit and halfway between 40 and 45, so 60 and 42.5. You subtract these values for the interquartile range, so 10 for fruit and 7.5 for veg. 1.5 times that is 15 or 11.25, and then calculate your outliers. So 15 lower than 10, 15 lower than 50 for fruits, nope. 11.25 lower than 35, nope, that's not a problem. That would be 23.75. On the high end for fruit, is it 15 higher than 60? Yeah, because that's going to be 75. On the veg side, it'd have to be 11.25 higher than 42.25, which is 53.75. No outlier on the veg side, but yes, outlier on the fruit side. This 80 is way bigger than all the other ones are between 50 and 60. They all bunched together. And then there's one fruit that has 80 calories per serving. I don't know what fruit that is. Okay, and how does that outlier affect the measures of variation for the calories? Okay, so the measures of variation is range and interquartile range, right? Those are the things we'd be looking at there. Does the fruit outlier affect the range for fruit calories? Absolutely, because if that wasn't there, the range would be 10 instead of 30, okay? The interquartile range would not be affected because you'd still have the same numbers for Q1 and Q3. Okay, but the range is severely changed if you throw out the outlier. Right, all the fruits are within 10 of each other, except for this crazy one that's up here at 80. All right, so measures of variability, that's quartiles and interquartile range and outliers. So there's 2 IXL topics that will cover those 2 things to do some practice on those before we get to, other examples in the next class.